Assalamu alaikum. Dear students, let's move down to the next part of chemical kinetics chapter. Here we will discuss about numericals on activation energy. In previous session we have gone through the activation energy formula, that is relationship for activation energy calculation we have seen. Same we are going to use it here for calculation of these numericals, right? So let's see. First question, rate constants of a reaction at 500 Kelvin and 700 Kelvin are 0.02 per second and 0.07 per second respectively. Calculate the value of activation energy EA, right? So here rate constants of a reaction at 500 Kelvin and 700 Kelvin are given to you. Means rate constants are nothing but the K values are given at two different temperatures, right? So lower temperature will be taken as the K1 value and the higher temperature rate constant will be taken as the K2 value, because with the increase in temperature rate of reaction increases as well as rate constants also increase. So here K1 will be equal to 0.02 per second. The rate constants of a first order reactions are given, right? So K2 is given 0.07 per second. What is the temperature given at T1? Capital T, because the Kelvin scale temperature is given to you directly, you can write capital T temperature. T1 is equal to 500 Kelvin and T2 is given 700 Kelvin. Okay, and you are asked to calculate activation energy EA. EA has to be calculated. R value, it remains constant, 8.314 joule per Kelvin per mole. In the relationship, if you are writing separately R, then you have to substitute this value, or directly we have calculated 2.303 into R, that is 19.147. That also can be taken, right? So what is the formula to calculate activation energy? Log of K2 by K1 is equal to EA by 2.303 R T2 minus T1 divided by T1 into T2, right? So this is the relationship to calculate activation energy, right? So R value, if you multiply here, you will get 19.147. Okay, so we'll substitute the values of given things. So log of K2 value is 0.07 divided by 0.02, that is equal to EA divided by 2.303 into R, it will become 19.147. 19.147. Temperature, higher temperature T2 is 700 minus T1 is 500 divided by 500 into 700, right? So rearrange and write. Now here what happens? Log of 0.07 divided by 0.02, you will be getting log of 3.5. If you divide this number, you will be getting log of 3.5 here. So you have to find out what is the log value of 3.5. That is equal to EA divided by 19.147 into this 700 minus 500, it will be 200 divided by 500 into 700, right? So here these two zeros I'll cancel with these two. Okay, So rearrangement, right? We have to calculate now EA. So EA has to be calculated. So EA becomes equal to log of 3.5 multiplied by 19.147 into 500 into 7 divided by 2, right? So you have to find out what is the log value of 3.5. So log value of 3.5 is equal to 0.544. It is 0.544, right? So single digit is there, characteristic will be 0. In the log table, you have to check 35 under 0, right? So 35 under 0, you will be getting 54441 or 5440, right? So into 19.147 into 500 into 7 divided by 2, right? So you will be getting the answer 0.544 multiplied by 19.147 multiplied by 500 into 2 into 7, sorry, divided by 2. Okay, so you will be getting the answer as 18,227.9, or you can make it as 18,228, or it will be written as, this will be in joule now. You will be getting the answer in joule, this EA value. इसको अगर आपको किलो जूल में लिखना है तो 3 डेसिमल आगे करके किलो जूल में लिख सकते हैं. सो वी कैन राइट EA is equal to 18.22 kilojoule per mole. This will be the answer, right? So this is the way you have to calculate the activation energy. So these questions are asked for 3 marks in the board examination. Okay, if they don't ask you the derivation for first order or zero order, they will definitely ask the numerical on this calculation of activation energy. So you have to write the formula, it carries 1 mark, correct substitutions 1 mark, and finally the final answer with correct unit should be there, it carries 1 mark, right? So it will be asked for 3 marks. Okay, we'll go to the next one. Rate of a reaction quadruples when the temperature changes from 293 Kelvin to 313 Kelvin. Calculate the energy of activation assuming it does not change with temperature, right? Now they have given what? The rate of a reaction quadruples, means it is increasing by 4 times when you are changing the temperature from 293 to 313 Kelvin, right? So two different temperatures are given, 293 and 313. So T1 I'll take it as 293 Kelvin. T2 will be taken as 313 Kelvin. So rate of a reaction quadruples, quadruple meaning is it is increasing by 4 times. So what they have given, instead of giving the rate constant values, you can take directly log of K2 by K1. They have given us log of 4. The ratio means the rate constant or the rate of reaction is increasing by 4 times. So if K1 is taken 1, K2 will become 4 based on the question given, right? Suppose that sometimes they will give you the rate of reaction triples or doubles, right? That time you have to write initial K1 will be taken as 1 and the triple means you have to take K2 as 3. And here they have given quadruple, so you are taking K2 as 4, K2 4, K1 1. So K 4 by 1 is nothing but 4. So whatever they have given the change, that value you can take here, right? So log of 4. Then EA has to be calculated. R value, as we know, it is 8.314 joule per Kelvin per mole, right? So again, write the correct formula. Log of K2 by K1, that is equal to EA by 2.303 R T2 minus T1 divided by T1 T2. Okay, so what is log of K2 by K1 given? Log of 4 equal to EA has to be calculated, and denominator part becomes what? 19.147. Okay, and here T2 is 313 minus T1 is 293 divided by 293 is T1 temperature multiplied by T2 is 313. Okay, so log of 4, we know that it is nothing but characteristic will be 0 because single digit is there, 0, and in the log table you have to check 40 under 0, and 40 under 0 is how much? It is 6021 equal to EA by 19.147 into 313 minus 293, that is equal to 20 divided by 293 into 313. Okay, so you are going to calculate what now? EA. Rearrange the values. EA is equal to, these values will come on this side, 0.6021 multiplied by 19.147 multiplied by 293 multiplied by 313 divided by 20. 20 नीचे आ जाएगा. Okay, see how much value you will get? 0.6021 multiplied by 19.147 multiplied by 293 multiplied by 313 divided by 20. You will be getting 52,863. राउंड ऑफ करे तो आपको जो है 52,863 मिलेगा. दिस वन आई विल राइट इज joule per mole, that is equal to what? If I write in kilojoules, it will become 52.86 kilojoule per mole, right? So this will be the answer. Okay, so this is the way you have to solve this numerical. Okay, next question. Rate constant of a first order reaction at 600 Kelvin is 1.6 into 10 raised to minus 5 per second. Calculate the rate constant at 700 Kelvin if its energy of activation is 209 kilojoule per mole. Given R is equal to 8.314 joule per Kelvin per mole, right? So here what they are asking is rate constant at a particular temperature is given. You have to calculate the rate constant at 700 Kelvin. Means K2 value has to be calculated because lower temperature it will be a K1 value. This will be K1, and at higher temperature it will be K2 value. So you have to calculate K2 value, rate constant at 700 Kelvin. You are given with the activation energy value also, and R value also is given to you, right? So let's begin. First we will write down the given things. K1, how much it is? 1.6 6 into 10 raised to minus 5. 1.6 into 10 raised to minus 5 per second. K2, it is given, it has to be calculated, right? T1 is given 600 Kelvin and T2 is given, how much it is? 700 Kelvin. EA value is given 209 kilojoule, right? And R value is 8.314 joule per Kelvin per mole. Okay. Now EA value is given in kilojoule. It has to be converted into joule form, as R value are taking in joule. Any of these should be converted to the same units. So we will change activation energy value in joules. So we can write it as 209, instead of kilojoule we'll write 000 joule, right? So this will be the value of EA. Okay, so substituting these values, we'll start this calculation of K2. So log of K2 by K1 is equal to what? EA by 2.303 R T2 minus T1 divided by T1 T2. Okay, now log of K2 by K1, I'll keep it as it is, equal to EA value is given 209,000 divided by, this will be 19.147 into T2 is 700 minus 600 divided by 600 into 700. Okay, log of K2 by K1 is equal to, so here what happens is you will be left out with 100 over here. Okay, यहाँ पे लिखता हूँ मैं 209,000 into 100 divided by 19.147 into 600 into 700. Okay, so this two zeros will cancel over here and these two zeros I'll cancel over here. So you will be left out with what? Log of K2 by K1 is equal to, multiply and divide, you will be getting denominator part, it has to be multiplied. So here you are left out with 2090 divided by 19.147 multiplied by 6 multiplied by 7. You will be getting the answer as 804.17. डिवाइड कर लो, कितना आता है देखो, 2090 divided by 804.17. You will be getting 2.5989 or 2.6 we can take, round off कर लेंगे, you will be getting 2.6. Okay, 2.5989 आता है, we'll round it off and write 2.6. So this is nothing but you got the value of log of K2 by K1. Okay, now if you take the log on the other side, it will become anti-log. So K2 by K1 is equal to anti-log of 2.6. Anti-log you have to find out for the value 2.6, right? एंटी लॉग फाइंड आउट करते वक्त क्या करना है, एंटी लॉग टेबल में आपको जो है 0.6 की वैल्यू 0 के अंडर देखना है, जो भी वैल्यू आता है लिखेंगे, उसके बाद ये जो रहेगा इसको आप पावर बनाएंगे, इट हैज टू बी मेड एज द पावर, राइट। सो K2 by K1 is equal to antilog of 0.6, you will be getting 3981, right? So after this, what you have to do is, after first number, place the decimal point into, you take this number as the 10 raised to power. It will become 10 raised to 2, right? So this will be K2 by K1 equal to 3.981 into 10 raised to 2. K1 value is given to you. You take this K1 value on the other side, multiply, what you will get, see here. So K2 is equal to, K1 value is 1.6 into 10 raised to minus 5 into 3.981 into 10 raised to 2, 10 raised to 2, right? So I'll write over here. So 1.6 into 3.981, it will be 6.36 or 6.37. K2 value will be 6.36 or 37 into, minus 5 is the power here, and here it is a 2, minus 5 plus 2, it will be minus 3. So you will be getting 6.37 into 10 raised to minus 3 as the power, and the unit will be per second. This is the value of K2. Okay. So this is the way you have to solve the numericals. Either they can ask you the calculation of activation energy. Many of the times they have asked calculation of activation energy only. If they ask you the calculation of rate constant also, you can solve like this, right? So when you are asked to calculate rate constant, keep as it is the log value. Once you calculate the right hand side part, whatever value you will get, you have to take its anti-log. It becomes easy for calculation. Otherwise, it will become a lengthy numerical, right? So practice these type of questions. Okay. So they are asked for 3 marks in the examination, right?